Hello friends, in this video, let us learn how to implement a stack using a linked list. We know we can implement a stack using an array. But if we implement the stack using an array, we need to specify the array size at the beginning, that is, at the compile time. And we cannot change the size of an array at runtime. So it will only work for a fixed number of elements. And what is the solution to this problem? The solution is we can implement the stack using a linked list. In a linked list, we can change its size at runtime. So let us see how to perform push and pop operations when we implement a stack using a linked list. We should create the linked list in the reverse order so that the head node will always point the last inserted data, which will be the top of the stack. So first, let us push a value into the stack. And at first, the stack is empty. So head equal to null. And we have the push function to push a value into the stack. And we will pass the value to be inserted into this function. Let the value to be inserted be 10. First, we have to create a new node to store this value. So use malloc function to create it. So we have struct node star new node equal to malloc of size of struct node. So a new node is created and now add the value to it. So write new node data equal to val. So 10 is added to this node. Now the node is ready and the next question is where to insert it. It should be inserted at the top of the stack, which will be the head of the linked list. So it should point to head. So write new node next equal to head. And now make it the head of the linked list. So one element is inserted into the stack. Now let us insert another element 20 to the stack. So call push of 20 and use malloc function to create a new node. So a new node is created and now add the value to it. So write new node data equal to val. So 20 is stored in it. So node is created with value and it should be pushed at the top of the stack or before the last inserted element, that is before head. So it should point to head. So write new node next equal to head. And now make it the head of the linked list. Now let us insert another element 30 to this stack. So call push of 30 and now use the malloc function to create a new node. So a new node is created and now add the value to it. So write new node data equal to val. So 30 is stored in the data part of the new node. So the node is created with the value 30 and it should be pushed at the top of the stack, which is head here. So this new node should point to head. So write new node next equal to head. And now make the new node the head of the linked list. So that is how push operation can be performed when we implement stack using linked list. Now let us see how to perform pop operation. So we know that push and pop operation is performed at the top of the stack. So from where should we delete the element from this linked list? It should be the head element which is popped and the next element will become the new head. So let us see this pop function here. When we call this pop function, the element at the top of the stack, that is the head of the linked list, will be removed. So first declare the pointer temp and check if the stack is empty, that is if head equal to null. And if it is, then deletion is not possible since the stack is empty. But here it is not. So go to else part and print the element which is to be popped. So print popped element is head data. So we will get the output popped element equal to 30. Now we need to delete head and make the second node the head. But if we delete head first, then there is no way to access the second element. So first copy head to temp and then make the second node the head. So temp equal to 3000 now. Now make the second node the head. So we have head equal to head next. So head equal to 2000 now. Now we can easily delete the old head which is in temp. So write free of temp and it is deleted. And that is how we can perform pop operation. Now let us call pop again. So first check if stack is empty, but it is not. So go to else part and print the element at top. So we will get popped element equal to 20. Now copy head to temp and make the second of the head by writing head equal to head next. So head equal to 1000 now, and now delete temp, and the operation is completed. Now let us call pop again. And first check if stack is empty, but it is not. So go to else and print the element at top. So we will get popped element equal to 10. So we will get temp equal to 1000. And now make the second node the head by writing head equal to head next. So head equal to null now. And now delete temp. So this node is deleted and the operation is completed. Now call pop again. And in this function, first we check if head equal to null, and it is. So it prints pop operation is not possible since stack is empty. So that is how we can perform push and pop operation in stack using linked list. Now let us discuss about the time complexity. As we just learned, in push operation, we only need to create the node with the value and make it point to head. So a constant time is needed. So the time complexity is order of 1. And in pop operation, we only need to copy head to temp, make the second node the head and delete head, which also takes a constant time. So again, the time complexity is order of 1.